Swayam Prabha. Digital India. Educated India.
Then other points which you have to look into the selection of the site is good runoff from the catchment is coming. That's why people always used to do that the dam just below the confluence of main river and a substream. Then the soil in the catchment does not contain harmful soluble salts and it is not erodible, right? Good forest. And then in the downstream side, there is a good area for irrigation. If it is not there, then we have to construct a very lengthy canal network to take the water from the dam to the command area. Right? So these are all some of the points, preferably a deep reservoir so that the evaporation loss will be very less, land cost per unit capacity is less prone to weed growth, right? Weed growth means when the dam is full, the water is under submergence. When the depth is small, more area will be under submergence. When even you draw the water for less than 1 meter, more area is exposed. So then there will be a huge growth of weeds. Unnecessarily next year when water comes, it will take more water than the water you draw for the downstream side. Then water quality, so that it depends upon the soil type, vegetation type on the upstream side. As far as possible, the dam site should be away from the flooding tributaries to mainly to prevent the sediment flow, and it should have impervious rock formation for minimizing the leakage in the riverbed. Otherwise, you store the water, next year all water goes into the soil. It will work as a percolation pond rather than a dam. Right? The reservoir banks, right, adjacent to the hilly region should have a good abutments for the stable construction of the dam. Right? The acquired land to be submerged in the reservoir should not be very valuable, like settlement of the population. That's what we also do, rehabilitation and resettlement. Resettlement and rehabilitation called as RR policies. Huge number of researchers are working on this. How to settle them? Because when I construct a dam across the river for a particular height, huge area, kilometer square gets under water. Whether any settlements are there, then we have to do a proper resettlement. The next is the site which we are selecting should be easily accessible through roads and railways during construction and after construction, right, for operation maintenance. Residential quarters for the field workers can be constructed there, or the office quarters after construction of the dam should be constructable. Then the cost incurred for the construction should not be excessive. These are all small considerations. Then after these 4 or 5, you select a particular site. For each and every site, we should do site specific investigations. What we have done so far is site selection. Site, not the site, the surrounding of the site. When I select each and every site, do the site investigation. That means it should be a sound and economical projects. It includes the study of various alternatives regarding the layout of the scheme. Right? If I do a dam at this site, what are all the other alternative constructions, other layout requirements? Right? So the final alternative selected site shall be fully justified so that after starting of the work, nobody should point out that this is the wrong site selected. So before selection, we have to do all the possible investigations. Once I select 2-3 site, how to do that? Once I select 2-3 sites for the dam construction, first one is to do a topographical survey. That means you do a contour map. I think you have studied in your geodesy. You have to do a contour map. This can be done either plane table surveying, traverse, aerial, photography, right? Or using all types of surveying methods, mainly to prepare a contour map to determine how much water will get spread between this area. There are three types of volumes, right? We have seen dead storage, useful storage, and flood storage. How to store it? Then area elevation curve, right? How to draw this area elevation curve? We will see one by one, right? Let us see. This is the map which site which we have selected for construction of a dam. Now I am constructing a dam across a bank. So then what happens? The water gets stored according to the contour like this. Let us say this is the main river, right, which I am going to, which I have, this is the site which I have selected for construction of the dam, the red line. Now what happens? This is the contour map I have prepared for the throughout the catchment. The area where this water gets to be stored is the water spread area. So now this contour line goes from 1, 2, 3, 4, 5, 6, 7. Right, that's good. Suppose if my height of the dam is up to the 2 meters level, then the area of submergence will be up to the area contour line of 2 meters. If my dam height is 3 meters, then the area of submergence will be at the banks of 3-meter contour. Then 4 meters, right? This 4-meter area gets submerged. Fourth, then 5 meters height of the dam, the 5 meters contour gets submerged. So as the, you can see that as the height of the dam increases, the area under submergence also increases. See, this is not the differential area. That means it is not just the area between 4 and 5. It is the cumulative area from the face of the dam to the 5. So when I increase the height, this is the reservoir elevation and this is the area under submergence. You can see that area in the upper axis 0 to 44 from right to left. As the reservoir elevation increases, initially when there is no reservoir, that is zero area, as the height increases, the area of contour goes on increasing. So the area, you see here, the area of 7 will be larger. The incremental area will also be larger. For example, the area between 2, 3 and 3 to 4. 3 to 4 will be much larger than the 2, 3. That is why as the height increases, height means elevation increases, the area of submergence also increases. Then how to find the volume? I know the height, but the area of submergence is not of equal depth at all locations. So near the dam face, it is an elevation difference of full. Then at the end, it is 0. So that means it goes like a triangle in radial directions. So then we can use our simple trapezoidal formula. Height and area between the contours 1 and 2 will give you the incremental area, incremental volume. So once I know the volume for each and every height between, you can find out what is the volume, right? As the capacity, as the elevation increases, the volume of water stored will also increase. And this volume of water is also called as capacity, right? See, that is why the dam height. So everybody says that why people are fighting when there is an increase of 11 feet or 6 feet. But you just see, for example, let us take a water dam height 156 meters to 162 meters. This is 6-meter difference. So what is the capacity? It's very small, 0, maybe 2 to 5. But the same 6-meter at very high elevation, when the dam height is 192 meters, if I increase 6 meter, then what is the capacity? It varies from 77 to 110. How much volume of water will get stored? Then what will be the increase in area for this up high level? It is from 30 to 42 hectares. So as the area and volume stored at higher and higher height of the dam will be more and more. And this curve we have to draw for different locations which we have selected. So you can use Kohn formula, Simpson's formula, whatever it is. It is a cumulative area, accurate estimation. These are all conventional methods. Nowadays we have different methods to estimate the volume. Once I fix this area elevation curve at different sides, and you can find out which is the most economical. Right? Area of submergence is less, at the same time volume of water stored is more. That means you are selecting a narrow valley. Sometimes the area under submergence will be larger, but volume of water stored will be smaller when compared to other site. Then your evaporation loss will be larger. Sometimes seepage losses will be larger. But the most economical section is narrow valley. That means area of submergence is less, but volume of water stored is more. Then after selecting this topographical, after doing this topographical survey, we can go for geological investigation, because sometimes the location says that a narrow valley is there, but foundation is not available good. Then I cannot construct a huge structure. Right? This geological studies includes the structural features of the underlying aquifer like fold, fault, fissures, right? Their nature and extent. Deep thorough investigation is required, right? Because the reservoir constructed should be watertight. Watertight means there will be seepages, but it will get stabilized over the period of time. But when I store the water and there is a fault or fissure below the foundation, all water goes through that to the downstream side. So before I use the water for the economical purposes, water in the reservoir is released in the downstream side because of natural fissures. Right? So then we have to do all this type of investigation. Then we have to check whether is there any sink or holes solution in the dam where I have selected this cross section. Then is there any landslide which when I store the water, the banks and everything gets saturated? Whether there is a potential area, potential site where the banks or hilly area can slide. That also we have to do in the geological investigation. That means I fix the dam height. So do in that contour, you have to go around and find out what is the area where there is a potential landslides. Then we have to assess is there any mineral deposits, valuable mineral deposits. Then is there any water condition, groundwater, right? Then seismic condition. Another important is also the material for the construction of the dam is available near the dam site. If then you go for a rock stone masonry or earthen dam, or you want to go for concrete dams. Then once I do the geological investigation, then do the foundation investigation. That means closely determine the properties of the foundation soil. Is there any shear zones, right? At what depth the weathered rock is available? At what depth the hard rock is available? What is the structural strength and weakness of the foundation stone? Is there any discontinuous in the foundation stone bedrock? These are all can be done. We cannot explore, excavate and see that. So people used to do exploratory boreholes. The borehole should be selected such that you have a clear picture. Sometimes what happens, you do a borehole at every 50 meter or 100 meter, you may be missing a small fracture or small fissures. That's why you have to do an appropriate borehole mechanism. Okay. These are all the materials. These are all different methods of exploratory bore wells. Then excavation of open pits and trenches or tunneling into the side of the valley, core drilling. All these methods foundation engineers will do. The second one is the most important, the meteorological and hydrological studies. What is the meteorological studies? On watershed plan, we should study what are all the prominent orographic features. Sometimes orographic precipitation will also causes filling the dam. Then what are all the annual ISO heights in that catchment area? Catchment area is the area from which the dam will receive the water. Then location of rain gauge stations. Is it already existing or we need to install and study? Is there any gauging station on the upstream side as well as downstream side? And then interstate boundaries, political boundaries, all these things we may have to go through in the meteorological studies. Then after collecting this data, first assess the weighted rainfall in the catchment. Either you use isohydral method or Thiessen polygon method. Isohydral method is the best method which will take care of the non-linearity in the rainfall between one station to another station. Then collect and evaluate the data for frequencies of heavy rainfall, so that you will study the flood studies. Then determine the standard project storm and maximum possible precipitation over that catchment area. Also analyze what is the maximum, minimum temperature, average wind speed, right, to find out the wave height, relative humidity. So analyze the meteorological parameters. Then in hydrological investigations, the first one is you analyze what is the possible discharge in the measure. If that is not available, you have to do the rainfall runoff relationship, assuming the gauging ungauged site. So once I know the volume of water flowing in the river, then we have to fix the size of the reservoir, okay, area under submergence, and the height of the dam, and then possible of estimating the irrigation and the power production potentials. Right? To do this, at least we need minimum 30 to 35 years of observed discharge data at the site where we are constructing the dam. If not, we need to do a proper estimation of this discharge data. Nowadays, throughout India, everywhere, this Central Water Commission has installed several gauging stations across almost all river basins in India. Hourly gauges and discharge during floods, that should also be observed. Once we did that, then do a rainfall runoff correlation. Then you have to fix the height and size of the dam. How to find this height and the capacity of the dam? There are three storages I told. One is dead storage, live storage, and flood storage. We will see one by one. Right? To know that, we should know what are all the different storages. The first storage or capacity is active capacity. Active capacity is nothing but the storage available for project purposes. Right? So this is normally between the minimum drawdown level to the maximum water surface. And this is also called as effective storage, useful storage, usable storage, effective storage, or effective capacity and useful capacity. Active capacity is nothing but useful. That means I may store thousands of 1000 million meter cube, but I may be able to draw only 200 million meter cube. Then that is the useful storage, right? Then this area capacity curve will help us to find out what could be the possible relationship between water spread and storage and elevation. Carryover storage is, I have estimated the discharge in a year at a site. Suppose if I use all the water flowing at a year, then for next year again, next year flow has to come, then only I can supply. Instead, in a year, whatever the water comes, I will be storing more than my demand. Then what happened? The rest leftover storage will be carried over for the next year. If next year is a lean period, that means less flow, then this carryover storage will be used. But most of our reservoir, we do only 1 year planning, right? Then the coefficient of storage and the reservoir factor, that is nothing but over the period of the year, the annual inflow is estimated. Inflow means the water flowing at a site. Every year it varies depending upon the rainfall. But I fix a constant capacity of the reservoir. Then I used to estimate a ratio called as inflow by capacity. So normally the capacity of the reservoir should not be the 100% flow, or it depends upon, because the annual flow is tagged always with probability. So that is where you estimate 75% dependable inflow. 50% dependable inflow is the capacity of the reservoir, so that the volume of water stored is used better, and downstream side also will receive the remaining flow, right? Then power storage. Sometimes I will need to estimate the power. Most of the dams, we store the water, and that water is used for power production, and same water is used for irrigation. But there may be some location where the water to be stored for power may not be useful for irrigation. It may be moving away from the main river. Then I need to store that extra water for power. Then flood. We have used several equations to estimate the flood. Then that much quantity of water has to be stored in the dam. That is called as flood control storage. And then I need to release it properly through the surplus VS. Right? Then the storage cycle is nothing but the period at the beginning and the end of the reservoir contents are the same. For example, we in India we always starts with our storage from the dead storage level. So every year, because we cannot draw below that dead storage level, so my reservoir is empty. So then the storage cycle is that year I receive good flow, my reservoir is flow. Then at what time again it becomes to the dead storage level, that is called as storage cycle. Most of our dams have a storage cycle of 1 year. That means if there is a monsoon failure, next that year I will not release any water to the downstream side. Then the surcharge storage capacity above the maximum operating level. I said that there are certain dams where I store the water even above the spillway through the gates. Sometimes it is storage as well as flood water. That is called surcharge storage. Then reservoir yield, like your catchment yield, reservoir yield is the assured minimum volume of water the reservoir can supply, also called as firm yield or safe yield. Okay, so these are all different definitions. We use it. Secondary yield, I think this is the quantity of water available in excess of safe yield. Average yield is the firm yield over the period of time. Right? Now I am showing you pictorial representation of various storages definitions in the river. This is the in this dam. This is the dam and this is the spillway crust. You see here the sediments gets deposited at the bottom and that is called as dead storage. And the height at which the dead storage cut is called as minimum reservoir level or minimum pool level. So the water will be drawn from that sluice way. The water stored above this minimum reservoir level up to my requirement is called as normal storage level. Then volume of water which is stored due to flood water is called as flood storage. Then during the flood, certain amount of water will be stored above the flood water, that is called surcharge water. Right? The level up to which the water stored totally is called as maximum reservoir level. Then up to the flood control, it is called as full reservoir level. That means the water is not surplusing from the dam, but it is at the brim level of my spillway crust. It is called as full reservoir level. Then minimum reservoir level is I cannot draw any more water. So the volume of water stored in dead is called dead storage. The volume of water stored in active storage is called as useful storage, and this is flood storage. Sometimes flood storage can also be counted as an active storage. And then the volume of water stored in the banks is called as bank storage. So this is the explanation for all these things. Normal reservoir level, the level corresponding to the gross storage, which includes both dead storage and live storage. Okay, that means the spillway is not discharging any water, it is stored. The maximum reservoir level is the level to which the water in the reservoir shall rise during the design flood. The space between this full reservoir level and maximum reservoir level is reserved for flood waters. Right? This is fixed by routing the flood throughout the catchment. Even after above this flood maximum reservoir level also, the freeboard of the dam, it depends upon the height of the water you are storing. It should be minimum 3 meters, right? That means there is a sufficient time for the executive engineer to operate the dam gates so that the water will not overflow the dam. That is freeboard of the dam. Right? Minimum reservoir level is the level at dead storage. So I cannot draw any water. People always say that, oh, I went there, there is a huge quantity in the water in the dam. Actually, that is the dead storage level, where you, by gravity you cannot draw the water, only by pumping you can do the drawing the water. Right? And these are all the different storages, as I said: flood storage, live storage, dead storage, valley storage, and bank storage. Each one has their own specific purpose. Right? This is much more clear. So this is the dead storage. This is inactive storage, or this I can use it only with a drought period. Then this is minimum drawdown level. That means the minimum drawdown level is the level at which I have to start supplying water for various demands. That is, see, this inactive storage is sometimes is required for the living beings on the upstream of the catchment, like animals, natural vegetations, all these things, right? So these are all different storages, right? And this is the bank storage is developed in the voids of the soil, cover in the reservoir area, right? Due to seeps. When water level drops down, again this water comes into the reservoir. Bank storage, the volume of water held by the natural river channel in its valley, right? So during the full reservoir level, that will act as the buffer store. Storage between full reservoir level and maximum reservoir level. This is temporary storing of the flood water. This portion. Storage. This is what we are going to use for various purposes like irrigation, right? That is between the dead storage to flood storage. Dead storage is the volume of water stored in an area where intended for sediments. Until the sediments are getting accumulated, water will be stored. Once sediments are, this volume is filled with sediments, you cannot find any water. Normally, this is taken as 10 to 25% of the gross storage. But nowadays, it depends upon the better studies of sediments. Now we will see how to estimate these three important storages. That is nothing but the live storage, dead storage, and flood storage. Now we will see the method how to find this live storage. This we have studied earlier also in runoff. This is estimated using a simple method called as double mass curve or ripple diagram. Nowadays we are using sequent peak algorithm method to estimate the live storage of a dam, right? So superimpose the hydrographs of stream flow and demand. It is not simple superimposing the hydrographs. It is the cumulative hydrographs, cumulative inflow over the period of time and cumulative demand over the period of time, and superimpose. Always start the demand from the peak of the cumulative inflow. Then the difference between these two will give you the storage. For example, the graph which shows here, this is A, C, E, right, C dash B. This is the cumulative inflow at a given site. Then I am estimating what is the demand. So my demand, cumulative demand starts either at from C or C dash. Then the vertical difference between these supply, that is inflow curve, and cumulative demand curve, S1 and S2 vertical, that is the storage. Select the maximum of this will become the live storage capacity of the reservoir. Right, this example I think we have solved it in our runoff class itself, right? Or we can do it in the another method called as sequent peak algorithm. When I have a sufficient number of data points, then estimate the cumulative surplus and deficit, find out the cumulative of the surplus and deficit. So my values, cumulative values may be increasing or decreasing depending upon the which is more, either deficit is more or surplus is more. Then the capacity between the sequent peaks and the troughs will give me the capacity of live storage. The maximum difference is taken as the live storage of the reservoir.